Okay, so recording is started. Good morning, students. This is a class of geotechnical engineering. So we are discussing on the module 2, part 2, that is seepage analysis of water. So till last class, we have discussed about different parameters of seepage analysis. We have discussed Laplace equation of two-dimensional flow of water through porous medium. We have discussed about velocity potential, stream function, and flow net also. Okay, and flow net is very important, and it's a very important considering that considering the stability analysis of dam. Okay, so to study a dam stability, one can utilize seepage. One can utilize the flow net concept for for stability analysis of dam. Okay. So last class we discussed about FlowNet and its application. Today we're going to do one problem, a numerical based on application of FlowNet. Then we'll study little about phreatic line and dam structure. Then we'll ended up the model 2. Okay. So first I'll share my screen here. So I'm just brushing up your memory. I think it is visual, right? My laptop is visual. So this kind of shape, if you can remember, we have discussed in the last class also, this is a flow net. Okay, this grid shape pattern are known as flow net, and it is not a physical thing, it's an imaginary line. Okay, it's an imaginary line drawn to study seepage or flow of water under pressure through a hydraulic structure, especially in case of dam. Okay, so this, if water is considered to be flow in this direction, so this the line parallel to the flow direction, it is known as flow line or stream line, and the line which are drawn perpendicular to the direction of the flow, they are known as equipotential line. And the equipotential line and stream lines are mutually perpendicular to each other. That means the angle between these two lines are 90 degree. Okay, and the area enclosed between two successive streamline and two successive equipotential line are known as field. Okay, these all are field, and a portion, this portion, and this portion, and a portion enclosed between two successive streamline, are known as flow channel. So in this particular diagram, you can see three flow channels are existing: 1, 2, and 3. And through each flow channel, it is considered that equal amount of water is flowing. It is delta Q is the amount of water flowing through each flow channel. Okay, fine. So these things already discussed in the last class, and we also discussed the application of FlowNet. So application of FlowNet, the FlowNet can be used to study. Okay, wait. FlowNet is used to study that amount to find out the amount of discharge passing through as a seepage under pressure through a dam structure. Okay, and how to find out the total discharge under seepage? By this derivation. So we also discussed this derivation in previous class. So total Q, the total discharge through a complete flow net, okay, that is Q, it is a summation of the discharge passing through each flow channel, that is delta Q. It is a summation of delta Q. Okay, it's depend on the how many number of flow channels are exist in a particular flow net. Okay, so considering total complete flow net, this is the equation that we have derived in the last class. Q is equal to KH NF by ND B by L, where K is your coefficient of permeability. Okay, coefficient of permeability. H is the total head due to which water flows from upstream to downstream. B and L are the dimension of a flow field in our flow net. B is the width, L is the length. ND is what? Numbers of potential drop. How many potential drop exist in a uh, particular flow net? Okay, and NF is what? The total number of flow channel in the flow net. So NF is your total number of flow channel, ND is your total number of potential drop. Okay, so here if you consider a square field, if you consider the square is approximately square, sorry, the field is approximately square, you will get B is equal to L. Okay, the dimension of the square field is equal. So this B and L can be cancelled out, and finally we can find out, we can achieve a general equation of discharge through a complete flow net given by the equation Q is equal to KH NF by ND. Okay, it's very important formula. Okay, so today we're going to discuss about one numerical based on this particular uh, formula. Okay, okay then. Okay, so here it is, one formula, sorry, one numerical here. Very, it's look like lengthy, but it's very easy to solve the problem. Okay, let me zoom a little bit. Okay, so what is given here? Here in the problem statement is given as for a homogeneous earth dam. Okay, homogeneous means made of same or similar material. Okay, for a homogeneous earth dam 52-meter high, that is the height of the dam is 52-meter, and 2 meter of free board. Okay, and I think this particular dam structure is familiar to you. Let me first, before going in this particular problem, let me again brushing up your that diagram for dam. Okay, let me go here, not this one, here I think, yeah. So let me again brushing up your mind related to dam. Okay, this Friedrich line also discussed in the last class, I guess. So this particular flow net is used to study the seepage within a dam structure or within a hydraulic structure. So how it is used, we're going to discuss. We already discussed. Again, we are going to repeat here. So here it is a line diagram of a dam. This is a dam. Okay, and water is flowing in this direction, suppose, and dam is constructed across the river, suppose. Okay, across the river, suppose, and this is the full reservoir level. Okay, full reservoir level, that means water is stored in this upstream phase. This is a downstream phase. Okay, and due to this weight of the water, it try to shift through the dam structure. It will follow this pattern. Okay, and it will go in this direction. Okay, and the top flow line, this particular top flow line is known as phreatic line, and all are flow lines. You can see these all are flow lines. So you can draw a flow net under a dam structure for study of seepage. Okay, these all are flow lines or streamline, and the line drawn parallel to the upstream face of the dam, they are considered as a potential equipotential line. Okay, these all are equipotential line. Okay, and they are making an angle 90 degree. Okay, it's not look like 90, but it is actually 90 degree. Okay, okay, and this is the freeboard. Okay, the height of the dam, if you consider height of the dam, it start from top to bottom. This is the height of the dam, and this is the freeboard. Freeboard from top face up to the full reservoir level. Okay, this is the freeboard. And about phreatic line or top flow line is defined as a line within a dam section below which there are a positive hydrostatic pressure exists in the dam. Okay, that means this phreatic line is considered as a top flow line, or you can say top streamline, topmost streamline, below which there is a positive hydrostatic pressure exists and above atmospheric pressure. Okay, like this. And about filter, this also I think it is already discussed. Anyway, so why this filter is, this is a structure. Okay, this is a component of a dam which is constructed uh, in the downstream phase or at the bottom of the downstream phase. And what is the specification of this filter? Okay, so if the filter is not, suppose there is no filter, this particular section is not provided here. So what is the main scenario of the flow may follow the path and may cross this downstream phase. Okay, this flow, the seepage of water may travel through this dam structure and may cross the downstream phase. And if it percolate the downstream phase, it may, uh, you know, it may fail the dam structure, or it may affect the stability of the dam structure. So to diverse the flow of water or to diverse the seepage away from the downstream phase, one special structure is constructed at the bottom of the dam. It's made up of a coarse aggregate and different material having larger voids, and it attract the flow, or it attract the seepage. So you can see all the water is going through this filter portion only, and by doing this, by providing the filter here, we can safeguard the downstream phase of the dam. Okay, this is a very basic definition that I have given. Okay, so this is the basic component of a dam. Okay, so let's go again to the problem. Yeah. Okay. So here, this is a problem. This is a problem statement is given as for a homogeneous R dam 52-meter high, that is height is given as 52-meter, and having 2-meter freeboard. Okay, that means from high full reservoir level, the top face of the dam having a extended height of 2-meter. Okay, so a flow net was constructed and following results were obtained. So particular flow net was constructed within a dam, not constructed actually to for study only. It was constructed on paper to study. Okay, not on paper only. So here some informations are given as for the flow net. Number of equipotential drop is given. Number of flow channel is given. That is 4 flow channels are given and 25 numbers of potential drops are exist. Okay. The dam has a horizontal filter of 40-meter length at its downstream end. Calculate the discharge per meter length of the dam if the coefficient of the permeability of the dam material is 3 times 10 to the power 3 centimeter per second. This is the value of the K is given to you. Okay. So it looked like very difficult problem statement, but it's very easy to solve. Only a simple equation it's you have to use. What you're asked to find out, you are asked to find out the discharge per meter length of the dam. That is, you need to find out total discharge per meter length of particular um, dam. Okay, and say it is a homogeneous dam. Now you can see the small diagram. It is also showing here. Total height of the dam is given as 52. Okay, and freeboard is 2-meter. So full reservoir level is at this point, and what is the height of the water will be 52 minus 2, that is 50, and this 50 meter will be considered as a h for hydraulic height. Okay, so h is, don't be confused, h is not considered as a height of the dam, it is considered as a head drop, and head drop is related to the height of the water. Okay, so here height of water is it is come as 50, 52 minus 2, that is 50 meter. So here we have to take h equal to 50. Okay, and the discharge per unit length, the formula is given as q is equal to kh nf by nd, where we have assumed a square field. We are assuming square field since it is not mentioned in the particular problem, and the value of L and B is not also, it is not given, so we can assume the field is square, so that we can cancel out L and B. So L and B is cancelled out here, and finally we got this formula KH and F by ND. Now we just need to put the value. So H equal to 52 minus 2, that is 50 meter. The numbers of flow channel is given as 4. Number of potential drop is given as 25. The value of K is given as 3 times 10 to the minus 3 centimeter per second. Okay, so here we are just converting since other values are in meter. Okay, H is in meter, so let's convert the value of K is meter per second. So simply just converting from centimeter per second to meter per second, that is 3 times 10 to the 5 minus 5 meter per second. Okay, this is just a unit conversion. Okay, now just put the value of K, H, and F by ND, will get the value of Q. Okay, just you have to do by yourself, you just try by yourself, you will find out the value of Q, and it will be in a unit of meter cube per second per meter length of the dam. This is the unit of Q. Okay, per meter length, that means you can see, if you see the three-dimensional, per meter length means you are taking the width of the dam is say 1, so per meter length of the dam we have considered. Okay, so for the whole dam structure, if you want to find out Q, just you need to multiply the length of the dam with this, since length of the dam is not mentioned here and you are not asked to find out, you are only asked to find out discharge per meter length of the dam, so this is will be your answer. Okay, so this kind of problem is it's look like difficult, but it's very easy to solve. Okay, fine, you just go through this. And one more thing is there, I don't want to go in very detail here, so very small thing I want to explain about the phreatic line here, since you're going to be a objective MCQ based question, so you don't need to go for this derivation. Anyway, I'll provide this. So we already discussed about phreatic line, okay, which is a top flow line. So there is a procedure to find out or to locate the phreatic line. Either you go for graphical method, either you go for analytical method. Okay, so you have to know that this particular phreatic line, the geometric shape of the phreatic line is parabola. Okay, you have to know this thing. The geometric shape of this phreatic line, you can see mathematically the shape of the phreatic line is a base parabola. You can see it is a base parabola. So in May exam may ask you about some small question. Okay, this is a filter, it is there, and using the property of parabola, using the basic property of parabola, you can determine the exact position of the phreatic line within the dam. Exact position of the phreatic line within the dam. Okay, so we are talking about dam with filter. Okay, so I don't want to discuss all these things here. I will share this particular notes. It's very simple mathematical term. Some steps are given here, you just go through this. Okay, how to locate a phreatic line within a dam, within an earth dam with filter by a graphical method. And this particular graphical method is proposed by Casagrande. This is very also important. This particular graphical method is suggested by Casagrande. Okay, this is a graphical method. You can go, how many steps are there? Total 5 steps are there. You just go through this. For understanding this particular procedure, you have to know the basic property of parabola. Okay, or basic principle of parabola. What is basic principle of parabola? I think here it is given here. I just want to read it out for you. Okay, the principle of parabola is that any point on the parabola is equidistant from the focus as well as from the directrix. Okay, so you just go through by yourself about a basic idea about parabola. What is parabola? What are the component of a parabola? I think for a parabola we have a axis, two axes will be there, one directrix will be there, one focus will be there. Okay, so if you consider this is a parabola, this line represents the directrix, this F represents a focus, okay, and these are the point on the parabola. Okay, so as per the property of the parabola or principle of the parabola, all the points, suppose this point P, this point is a point on the parabola. This point is equidistant from the focus and the directrix. Okay, so if you measure this distance and if you measure this distance, PF will be same. It is the principle of parabola. Okay, so based on this particular simple principle of parabola, base parabola, the fading line is drawn graphically. Okay, you just go through this. So total 5 steps are there. You just go through this. I will share this. Okay, this is about graphical method, and this is some analytical method. Okay, this is also based on this basic principle of parabola. If you can understand the graphical method, it is very easy to understand the analytical method also. Okay, so this is the thing all we need to discuss here for CPS analysis. There are lots of things are there. For this semester, I don't want to discuss all these things. We have discussed only some basic things only in this particular semester. Okay, there are lots of other concepts also exist to study CPS analysis of uh, within a dam structure. Okay, so with this I just want to complete the this class. I want to close my sharing here. Okay, okay, so next class we'll jump to that last module. Okay, that is your self-study investigation. We need one or two class to complete particular text chapter, and then the remaining other in future classes we're going to solve some numerical on index property of soil from that first module. Okay, and after that we're going to finish our syllabus. Okay, okay. So with this I just want to close my recording and I'm just going to take your attendance now. Okay, let me stop my recording here.